The paper of the day is OLTP on hardware islands. It's a 2000 product. Paper performs a detailed performance analysis of OLTP deployments in servers with multiple cores per CPU and multiple CPUs per server. Paper compares different database deployment strategies where they vary the number and size of independent database instances running on a single server, from a single shared everything instance to fine-grained share nothing configurations. They quantify the impact of non-uniform hardware on various deployments by first examining how efficiently each deployment uses the available hardware resources, and second, measuring the impact of distributed transactions and skewed requests on different workloads. Finally, authors argue in favor of shared nothing deployments that are topology and workload aware and take advantage of fast on-chip communication between islands of cores on the same system. Experiments and benchmark. In order to evaluate the performance of various shared nothing deployments in multi-socket, multi-core hardware, they implemented a prototype shared nothing transaction processing system on top of the Shore MT storage manager. They opted for Shore MT as the underlying system since it provides near linear scalability on single multi-core machines. Shore MT is the improved version of the Shore Store Manager, originally developed as an object relational data store. They run a modified version of the TPCC benchmark for evaluations. There are three key contributions of the paper. First, they provide experimental evidence of the impact of non-uniform hardware on the performance of transaction processing systems and conclude that high-performance software has to minimize contention among cores and avoid frequent communication between distant cores. Their experiments show that fine-grained shared nothing deployments can achieve more than 4 times as high throughput as a shared everything system when the workload is perfectly partitionable. By contrast, when the workload is non-partitionable or exhibits skew, shared everything achieves twice as high a throughput as shared nothing. Therefore, there is no unique optimal deployment strategy that is independent of the workload. Third, they demonstrate that a careful assignment of threads to islands of cores can combine the best features of a broad range of system configurations, thereby achieving flexibility in the deployment as well as more predictable and robust performance. In particular, islands-aware thread assignment can improve the worst-case scenario by a factor of 2 without hurting the best-case performance much. Coming to PS score, overall it's a nice read, so it gets 9 out of 10 on readability with 12 pages long. It scores 8 out of 10 on length. Reproducibility and repeatability will be challenging, so it gets 8 out of 10. Industry value and learning meter is high, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.